Welcome to this video on interpreting the correlation coefficient. After watching this video, you will be able to answer the following questions. What is a linear correlation coefficient? What does a negative linear correlation coefficient mean? What does a positive linear correlation coefficient mean? What does a linear correlation coefficient of 0 mean? And lastly, the student will also be able to determine the relative strength of the correlation by comparing R values. In the previous video on scatter plots and correlation, we alluded to this idea that some relationships between variables may be stronger than others. For example, the relationship between content mastery and score on a test would be stronger than the relationship between the amount of rest a person has the night before the test and their score on the test. It is true that the amount of rest affects a person's ability to retain and recall information, but no amount of rest will increase a person's score if they don't know the test material. Statisticians quantify the strength of a relationship between two variables using a measurement called the linear correlation coefficient, R. Let's look at the correlation coefficient spectrum. As you can see from this image, the value of the linear correlation coefficient R ranges in value from -1 to +1. We can see right in the middle, we have a correlation coefficient of 0. A correlation coefficient of 0 means that there is no relationship between the two variables. As we move right on the spectrum towards a positive R, we can see that the strength of the relationship between the two variables is increasing. And we can see that any positive R value means that we are going to have a positive correlation, which means that our linear regression equation is going to have a positive slope. In other words, as the x value increases, our y value is also increasing. If we come over here and we look to the left side for negative R values, we can see that we have negative slopes. This means that there is a negative correlation between our two variables. In other words, as the x variable increases, the y variable is decreasing. So again, if we have a negative R value, that means we have a negative correlation, which is a negative relationship between these two variables. And if we have a positive R value, that means there is a positive correlation, implying a positive relationship between these two variables. Again, as we get closer and closer to 0, we have weaker correlations. And as we move away from 0 in either direction, left or right, the strength of the relationship between the two variables will increase. Let's summarize this in some actual statements. The linear correlation coefficient is represented by the lowercase letter r. The value of the linear correlation coefficient r will always be between negative and +1. The sign of a correlation coefficient gives the direction of the association. A positive correlation coefficient, r greater than 0, means there is a positive relationship between the two variables. In other words, as x increases, y increases. A negative correlation coefficient, or r less than 0, means there is a negative relationship between the two variables. That means that as x increases, y decreases. A linear correlation of exactly +1 represents a perfect positive correlation. A linear correlation of exactly -1 represents a perfect negative correlation. In real data, the correlation coefficient is rarely exactly 1 or -1 because these values imply that all the data points fall exactly on a single straight line, which is highly unlikely. A correlation near 0 corresponds to a weak linear association. A correlation close to either -1 or +1 corresponds to a strong linear association. What does a positive linear correlation coefficient R tell you about the association between the two variables? Pause this video, write down your answer, and then unpause it to see if you are correct. If the R value is positive, this suggests a positive correlation between the two variables. That means as the X variable is increasing, the Y variable increases as well. Notice that means that our linear regression equation is going to have a positive slope. What does a negative linear correlation coefficient tell you about the association between the two variables? If the R value is negative, this suggests a negative correlation between the two variables. That means as the X variable increases, the Y variable decreases. To determine the strength of the linear correlation coefficient, we need to examine the absolute value of R. The strength of the correlation coefficient is unrelated to whether the coefficient is positive or negative. Which value represents a stronger correlation? R equals 0.4 or R equals negative 0.7? To answer this question, we need to find the absolute value of both coefficients. The absolute value of 0.4 is 0.4. The absolute value of negative 0.7 is 0.7. 0.7 is larger than 0.4. So a linear correlation coefficient of negative 0.7 represents a stronger correlation coefficient. Notice on the spectrum, R equals 0.4 is about halfway between 0 and 1. It's 0.4 units from 0. Negative 0.7 is much closer to an R value of negative 1, or a perfect negative correlation. It is 0.7 units from 0. Therefore, because negative 0.7 is farther from 0 on this number line, it therefore represents a stronger correlation between the two variables. Notice that the sign of R does not give us any information about the strength of our correlation. It only tells us the direction of our correlation. Remember, the farther from 0 on the number line an R value is, the stronger the correlation it represents.